all these characteristics for number 5. So I need everybody at this moment to type number 5, the equation, into your y equals if you haven't already. Okay, negative x to the 4th plus 3x squared plus 2x plus 2. Okay, type it in, press graph. I know you have the picture on your paper there, but not all those points, maximums, and minimums, and intercepts happen at whole numbers. So we need our calculator for that. All right, so we're going to go through this list. We're going to list these for all these problems, but we're just going to use number 5 as an example. The domain, always all real numbers. Okay, that's an automatic answer. You shouldn't have to think about that. The domain is all real numbers. I kind of start with the easy stuff. Domain, the y-intercept. Okay, the y-intercept is 0, 2. Okay, you must write it as a point. When we have a quiz on this, and I ask you for the y-intercept, you have to write it as a point. If you don't write it as a point, or if you get your point flip-flopped, I'm going to take off points. Yes, that's picky, but it's got to be correct. Okay, x-intercept. How do we find our x-intercepts? Okay, second trace 0. Okay, second trace 0. It's not number 5. Number 5 is intercept. Number 5 is intersect, not intercept. So it's number 2, 0. Okay, you got to move your cursor on the left side, which for the one on the left is below the x-axis. The right bound is above the x-axis. So one of our x-intercepts is negative 1.592. Please round to 3 digits after the decimal. 0. It has to be written as a point as well. Okay. All right, we have another one. Okay, this is a 4th degree. We're expecting 4, but we only have 2. That's okay. Just so we get the 2 that are there. Okay, so we do it again. This time the left bound is above the x-axis. That relationship flip-flops and the right bound's below. So the other x-intercept is 2.0990. Now, I think earlier today when I did this, my calculator didn't tell me that it was 0. Does anybody have the E stuff on it? Yeah? Okay. Just don't forget, when it has E and the negative 12 after it, that's scientific notation. That's times 10 to the negative 12. That's a super tiny number. Okay? You can see on the graph, you're sitting on the x-axis. The y value is 0. Okay? I don't know what I did differently this time than I did earlier this morning because I had the E when I did it in first period. So anyways, sometimes it'll give you 0, sometimes it'll give you that other approximation. But if you're talking about the x-intercept, the y value, automatically 0. Okay? But do make sure that the cursor is in the right spot. Okay? Make sure that it is showing you the point there on the x-axis. Okay, extrema. We have 2 maximums. Okay, we have 2 maximums. So second trace maximum is number 4. Okay, I'm going to go all the way to the one on the left. I like going left to right. So I'm going to go all the way to the one on the left first. Left bound, right bound, enter. Okay, now here's something else to talk about. Negative 0.999999998. That's negative 1. Okay. Once again, calculator doing its approximation thing. Did yours give you negative 1? See, Jordan's gave her a negative 1. I don't know why. Okay, it is negative 1, 2 is that maximum point right there. All right, since we're moving left to right, let's find the minimum that's there in the middle. Okay, there's nothing magical about the order that I'm doing these in. It's just the order I like to do it. That minimum is negative 0.366, 1.652. Okay, and we got one more maximum to find, so second trace 4. Left bound, right bound. Okay, 1.366, 6.848. Okay. Now, I'm going to really quickly sketch this up here so I can show you a couple of things that I want you to do on your paper. Okay, so here's what I want you to add to your paper. You should already have those vertical lines that are passing through your maximums and minimums. And I drew my graph too close. Oh, good grief. Let's try again. There we go. Just exaggerate it a little bit. All right, so you should already have those vertical lines drawn through your maximums and minimums. So you should have 3 lines on your graph there. At the bottom of those lines, I want you to put the x value of the maximum or minimum. So we've got -1, -0.366, and 1.366. And on like the far left side of your graph, down there as well, I want you to put -infinity on the far left side, and I want you to put positive infinity on the far right side. We're going to use that here in a minute, but I wanted to do it while we were talking about the maximums and minimums. So put the x coordinates of those points, because that's if I was writing the equation of those vertical lines, it would be x equals -1, x equals -0.366. Vertical lines are x equals. Okay? All right. Let's see here. Something we need to talk about. Since we have so many maximums and minimums, let's get a little bit more specific with their names. Okay? -1, 2 is what we call a local or a relative maximum, because it's not the maximum y value that our function will achieve. It's just a local maximum. It's a little bit of a hill in our graph or a peak in our graph, so it's a local or relative. The other one, 1.366, is what we call the absolute maximum, because that is the highest y value that our function will achieve, is that point right up there. That's the absolute max. Okay, and then our minimum in this case is another local or relative minimum. It's not the smallest y value that our function will achieve. It's just a valley in our graph, so it's a local or a relative minimum. Not all graphs will have an absolute maximum or minimum. For example, odd functions do not have absolute maximums or minimums, because one end goes up, one end goes all the way down. So it keeps on going for forever. You never hit an absolute maximum or minimum for an odd degree function. You do for an even degree. Speaking of, that leads us into the range. Okay, our range here, since that's a maximum, all of our y values are less than or equal to the y value of our absolute maximum. All of our y values are less than or equal to the y value of our absolute maximum, 6.848. Now, you can also write that in interval notation, okay? You always go least to greatest. So the smallest y value that we can have is -infinity. The biggest y value that we can have is 6.848. Okay? In case that interval notation shows up somewhere down the road. It will show up in pre-calc, if not before then on the final exam. Okay? So that says the same thing as the inequality. If you're more comfortable with the inequality, that's fine. You can use that. But you do need to be aware of what this says. This is the least y value that we can have. This is the greatest y value that we can have. It's always least to greatest when you do interval notation. Bracket versus parentheses. Infinity always gets a parenthesis. We can equal 6.848, so we put a bracket. Okay? We can equal 6.848, so we put a bracket. If we just got super, super, super close to it, but we couldn't actually equal it, then we would use a parenthesis. Okay? Bracket means you include that value. Parentheses means that it's not included. You get as close as you possibly can to it. All right, almost there. End behavior. Okay, let's talk about the ends of this function. As x approaches negative infinity, okay, the left side, where are our y values going? Where are the y values going on the left side? Down, decreasing, negative infinity. On the right side, as our x values approach positive infinity, the right side, positive. X is positive on the right side. You're wondering why I'm saying that so much, because people are confused by this notation. What are the y values doing on the right side? Same thing, negative infinity. They're going down, they're decreasing, they're falling. Because it's an even function, both ends do the same thing. All right, last part we have to do is our intervals of increasing to decreasing. So this is why I told you to label those values at the bottom of your graph. We're going to start on the left, and we're going to go all the way to the right, and we're going to include all those numbers. So what is our function doing first? Increasing or decreasing on the left side? Starting on the left, is it increasing or decreasing first? Is it blue or red? It's increasing, okay? So, starting at the far left, at negative infinity, until we get to -1, our function's increasing. Then it decreases for a little bit. So, from -1 to our next point, -0.366, it's decreasing. Then it's increasing again. From -0.366 to our next cutoff, 1.366, it's increasing. And then from that point on, it's decreasing. So from 1.366 to positive infinity, it's decreasing. I think that's the easiest way I've ever explained this, so hopefully it makes sense. Do I need to run through it again? Using what I've got in purple up here, using these values. You start on the left, you hit every single one of them. Okay? So negative infinity, -1, it's increasing. -1 to -0.366, it's decreasing. Typically, those are going to alternate. Okay, as you're moving from left to right, you should bounce between increasing and decreasing. Just depends on which one you started with. Doesn't make sense right now. Might not make sense in a second when you have to do it, but doesn't make sense at this moment. Yes? Okay. So